The Unraveling Equilibrium, a comprehensive examination of global warming and the human predicament. For the vast majority of the 4.5 billion years of Earth's existence, the climate has been a story of slow geological transformation driven by volcanic outgassing, variations in solar orbit, and the silent respiration of the biosphere. Yet, in the most recent sliver of this timeline, a mere 2 centuries, a single species has unwittingly become the primary architect of atmospheric change. Global warming, the sustained increase in Earth's average surface temperature, is no longer a speculative hypothesis confined to academic journals. It is the defining physical reality of the 21st century. It is a phenomenon that transcends meteorology, reaching into the arteries of our economies, the stability of our geopolitics, and the ethical contract we hold with future generations. To understand global warming is to understand the unintended consequences of human progress, the immutable laws of physics, and the profound vulnerability of the systems upon which civilization rests. The unseen blanket, the physics of the greenhouse effect. At its core, the mechanism of global warming is elegantly simple and scientifically uncontested. It hinges on the principle of radiative forcing, the balance between incoming solar energy and outgoing infrared radiation. The sun bathes the Earth in shortwave radiation, which passes relatively unimpeded through the atmosphere, warming the land and oceans. The Earth, in turn, re-emits this energy as long-wave infrared radiation. Were it not for the atmosphere, this heat would escape directly back into the frigid vacuum of space, leaving our planet a frozen, lifeless sphere with an average temperature of approximately minus 18 degrees Celsius, 0 degrees Fahrenheit. Fortunately, Earth possesses a natural blanket, greenhouse gases, GHGs, molecules such as water vapor, H2O, carbon dioxide, CO2, methane, CH4, and nitrous oxide, N2O, are uniquely structured to absorb and re-radiate this outgoing infrared energy, trapping warmth in the lower atmosphere. This natural greenhouse effect is essential for life, maintaining a hospitable global average of roughly 15 degrees Celsius, 59 degrees Fahrenheit. The crisis of global warming does not arise from the existence of this effect but from its amplification. Since the Industrial Revolution, human activity has been injecting vast quantities of long-buried carbon into the atmosphere at a rate unprecedented in geologic history. The burning of fossil fuels, coal, oil, and natural gas represents the liberation of carbon that was sequestered over millions of years in ancient swamps and seabeds. This combustion combines carbon with oxygen to produce the primary antagonist of our era, carbon dioxide, CO2. According to continuous monitoring at the Mauna Loa Observatory in Hawaii, atmospheric CO2 concentrations have surged from a pre-industrial baseline of approximately 280 parts per million, ppm, to over 420 ppm today, a 50% increase in less than 200 years. Ice core data from Antarctica provides an unbroken record stretching back 800,000 years, showing that CO2 levels have never exceeded 300 parts per million in that entire span until the mid-20th century. This influx of CO2 thickens the atmospheric blanket. More outgoing infrared radiation is absorbed and redirected back to the surface. The result is a steady accumulation of thermal energy within the Earth system, manifesting as a long-term measurable rise in global mean surface temperature. The physics underpinning this process were first articulated by Eunice Newton Foote in 1856 and quantified by Svante Arrhenius in 1896. The predictions they made over a century ago align with the thermometer readings of today with unsettling precision. The empirical indictment. Observable symptoms of a feverish planet. Skepticism is the bedrock of science, but empirical data leaves no room for doubt regarding the planet's fever. The instrumental temperature record, maintained by independent agencies like NASA's Goddard Institute for Space Studies and the UK Met Office, unequivocally shows that the Earth has warmed by approximately 1.2 degrees Celsius, 2.2 degrees Fahrenheit, since the late 19th century. While a single degree may sound negligible, In the context of planetary energy budgets, it is catastrophic. The difference between the last ice age and our current interglacial period was a global temperature shift of only about 4 to 6 degrees Celsius. This energy imbalance manifests most visibly in the cryosphere, the frozen parts of our world. Glacial retreat is a global phenomenon, from the Alps and Himalayas to the Andes and Alaska. These rivers of ice, which supply fresh water to billions of people, are shrinking at accelerating rates. Perhaps more alarming is the fate of the Greenland and Antarctic ice sheets. Recent satellite gravimetry data from the GRACE mission shows that Greenland is losing ice mass at a rate of approximately 270 billion metric tons per year. This loss is driven not just by surface melt, but by the calving of icebergs from glaciers that are flowing faster toward the sea as warm ocean water undercuts their grounding lines. In the Arctic, the effects are amplified by a process known as Arctic amplification. As highly reflective sea ice melts, it exposes darker ocean water. Instead of reflecting sunlight back into space, the albedo effect, the dark water absorbs the solar radiation, heating the ocean further and melting more ice in a self-reinforcing feedback loop. The minimum extent of summer Arctic sea ice has declined by roughly 40% since satellite observations began in 1979. The oceans themselves have absorbed more than 90% of the excess heat trapped by greenhouse gases. This ocean heat content is rising relentlessly, providing the fuel that supercharges tropical cyclones and storms. Warm air holds more moisture, about 7% more for every 1 degree Celsius of warming, leading to a marked increase in the frequency and intensity of extreme precipitation events and rain bombs. Furthermore, the absorption of CO2 by seawater is altering the very chemistry of the ocean through a process called ocean acidification. As CO2 dissolves, it forms carbonic acid, lowering the pH of the water. This chemical shift threatens the ability of calcifying organisms, corals, pteropods, oysters, and clams, to build their calcium carbonate shells and skeletons, threatening the foundation of the marine food web. The driver's more than just carbon dioxide. While CO2 is the primary control knob on long-term warming due to its atmospheric longevity, it persists for centuries to millennia. It is not the sole agent of change. Methane, CH4, the main component of natural gas, is a far more potent greenhouse gas on a 20-year timescale, trapping over 80 times more heat than CO2. Sources of methane include agriculture, enteric fermentation in cattle and rice paddies, fossil fuel extraction, leaks from wells and pipelines, and the decay of organic waste in landfills. Disturbingly, the thawing of permafrost, the frozen ground of the northern hemisphere that holds twice as much carbon as the entire atmosphere, threatens to release vast quantities of both CO2 and CH4 as microbes awaken and decompose millennia-old organic matter. This represents one of the most dangerous potential tipping points in the climate system. Once thawing reaches a certain threshold, it becomes a self-sustaining, unstoppable source of emissions regardless of human action. Nitrous oxide, N2O, released primarily from the overuse of synthetic nitrogen fertilizers in industrial agriculture, is another potent long-lived gas. Meanwhile, aerosols, tiny particles of pollution like sulfates from coal plants, have a net cooling effect by reflecting sunlight. Paradoxically, as nations reduce air pollution for public health reasons, this masking effect diminishes, potentially unmasking the full force of the underlying greenhouse warming. Consequences cascading through civilization. The 1.2 degrees Celsius rise we have already locked in is not an abstraction, it is a force multiplier for human suffering. The World Meteorological Organization reports a five-fold increase in weather-related disasters over the last 50 years. Water and food security. The hydrological cycle is intensifying. Wet areas get wetter, dry areas get drier. Subtropical regions, including the Mediterranean basin, southern Africa, and parts of Australia, are experiencing severe multi-year droughts that devastate agriculture and fan the flames of catastrophic wildfires. Conversely, warmer air dumps record-breaking rainfall elsewhere. In 2022, Pakistan experienced a monsoon on steroids, submerging one-third of the country underwater, displacing 33 million people and costing over $30 billion in damages. Crop yields for staple grains like corn, wheat, and rice are stagnating or declining in many tropical regions due to heat stress on plants. Sea level rise. Coastal cities are on the front lines. Thermal expansion, water taking up more space as it warms, combined with meltwater from land ice is driving sea levels inexorably upward. The current rate of rise is over 3.7 millimeters per year and accelerating. By 2100, even under moderate emission scenarios, sea levels could rise by 0.6 to 1.0 meters, 2 to 3.3 feet. This may not sound dramatic, but it compounds the destructive power of storm surges. A storm like Hurricane Sandy or Typhoon Haiyan, riding on top of a higher baseline ocean, pushes saltwater further inland than ever before, poisoning aquifers, overwhelming drainage systems, and rendering neighborhoods uninsurable and ultimately uninhabitable. Human health and migration. Heat is the deadliest form of extreme weather. Prolonged heat waves like those that scorched Europe in 2003 and the Pacific Northwest in 2021 kill thousands of vulnerable elderly and outdoor workers through heat stroke and cardiovascular failure. The geographic range of vector-borne diseases like malaria, dengue fever, and Lyme disease expands as warming winters allow mosquitoes and ticks to survive at higher altitudes and latitudes. Perhaps the most destabilizing consequence is climate migration. When drought destroys harvests in the Sahel or seawater swamps, rice paddies in the Mekong Delta, people are forced to move. The World Bank estimates that climate change could force over 140 million people to migrate internally within their own countries by 2050, creating immense pressure on urban infrastructure and social cohesion. The spectrum of solutions. Mitigation and adaptation. Facing this existential challenge requires a two-pronged approach: mitigation, stopping the problem from getting worse, and adaptation, learning to live with the changes already underway. Mitigation, the energy transition. The cornerstone of mitigation is the rapid decarbonization of the global economy. This means a wholesale transition away from fossil fuels toward a portfolio of clean energy sources. The good news is that the technology curve is bending favorably. The cost of solar photovoltaic power has plummeted by nearly 90% over the last decade, making it the cheapest source of electricity in history across most of the world. Wind power, both onshore and offshore, has seen similar cost reductions. Electrification is the key strategy. By shifting transportation, electric vehicles, heating, heat pumps, and industrial processes to run on electricity, we can centralize the pollution problem. If that electricity is generated from renewable or nuclear sources, emissions plummet. However, intermittent sources like wind and solar require massive investments in grid modernization, energy storage, batteries, pumped hydro, and long-distance transmission lines to ensure reliability on calm, cloudy days. Beyond energy supply, we must address demand-side efficiency and land use. Regenerative agriculture practices can restore soil health, allowing farmland to sequester carbon rather than release it. Halting deforestation, particularly in the Amazon and Congo basins, is critical, as these forests act as the planet's lungs and air conditioners. Technological solutions like direct air capture, DAC, which scrubs CO2 directly from the atmosphere using giant fans and chemical processes, are intriguing but currently expensive and energy-intensive. They are a tool for cleaning up legacy emissions, not a substitute for immediate cuts. Adaptation, preparing for a changed world. Even if we stop all emissions today, the CO2 already in the air commits us to decades of further warming and sea level rise. We must therefore adapt. This involves resilient infrastructure, building seawalls, elevating roads, planting mangrove forests as natural storm barriers, and redesigning urban drainage to handle 1,000-year rain events. It also requires agricultural innovation, developing drought-tolerant crop varieties and shifting planting zones. Crucially, adaptation requires financial justice. Small island nations like Tuvalu and Kiribati, which have contributed almost nothing to the problem, face existential threats from rising seas. The world's poorest farmers, who lack irrigation and insurance, are most vulnerable to erratic monsoons. The international principle of common but differentiated responsibilities acknowledges that wealthy nations, which grew rich on fossil fuels, have a moral and practical obligation to finance the clean energy transition and adaptation measures in developing countries. Conclusion. The unfinished chapter. Global warming is not merely an environmental issue, it is a mirror reflecting the profound impact of human enterprise on the geophysical forces of the planet. It reveals the unsustainability of a linear, extractive economy operating on a finite, circular world. The 2,000-word limit of this essay allows only a glimpse into the complexity of the challenge, yet the trajectory is clear. The current path leads toward a destabilized climate, characterized by relentless heat, food insecurity, and mass displacement. However, despair is not a strategy. The same human ingenuity that unlocked the power of coal and oil is now capable of harnessing the sun and the wind. The same economic systems that externalize the cost of carbon are capable of internalizing it through smart policy and innovation. The story of global warming is, at its midpoint, a tragedy of the commons. But the final chapters remain unwritten. Whether they detail a descent into climate chaos or a hard-won transition to a sustainable, equitable future depends entirely on the choices we make as a global community within this single critical decade. The science has spoken with a clear voice. The onus is now on our collective will to listen and act.